Alright, we're going to try to record problem 4 and see if we have any more luck. Alright, so on problem 4 we have, during a storm, Matt's car was dented by a hailstone. It gives you the depth of the dent and the mass of the hailstone and the speed, and you're looking for the average force. So I said, well, I know that the depth of the dent is 0.0020 meters because they gave it to me in centimeters. I know the initial speed was 20 meters per second. The final speed was 0. And I know that the mass of the hailstone was 0.012 kilograms. So I solved for the acceleration by saying that acceleration is equal to Vf squared minus Vi squared over 2b, but I think I could have also said is delta Ke, change in kinetic energy, is equal to the work done. So I could have said 1/2 m being 0.012 kilograms, Vf squared, which is 0, minus 1/2 m 0.012 kilograms times Vi squared, which is 20 meters per second squared, is equal to the force times the distance, and the distance was 0.002 meters. So if I did that correctly, I would get the force to be a negative, and when I did it, I got it to be a negative 1,200 newtons. Because this mathematically, this right here is going to be 20 squared, which is 400. Half of 400 is 200. And 200 times 0.012 would give me I'd get 24 something, and then I'd divide it by that and get that answer right there. So I don't have a calculator here to finish the math out, but I think you can handle that. Alright, number 5. Number 5 said that we have Anna, whose mass is 50 kilograms, leaves a ski jump with a velocity of 21 meters per second. So what is her momentum? So her mass was 50 kilograms. She left with a velocity of 21 meters per second. So momentum is just P, it's equal to mv. So 50 kilograms times 21 meters per second is going to give her a momentum of 1,050 kilogram meters per second. Okay, number 6. Number 6 said Reggie Jackson hit a 0.150 kilogram ball. The ball was initially going toward Mr. Jackson, so it was moving at 36 meters per second. The ball was hit by Mr. Jackson, so the direction changed, so I'm going to make that a negative 45 meters per second. And then the ball was in contact with the bat for 0.002 seconds. And they're going to ask me to find the force delivered by the bat on the ball. So I'm going to say that F delta T equals M delta V. So F, my delta T was 0.002 seconds. My mass was 0.150 kilograms. My change in velocity was final, negative 45, minus initial, which is 36. So I have a negative 81 right there times 0.15, and then that gets divided by 0.002. And so I find the force delivered is negative 6,075 newtons. And the negative just tells me that it's moving in the direction that the ball left the bat with, so that's fine. Number 7. Number 7 talks about at a state fair, Bob is throwing a ball trying to knock over a bottle. And so what we know is that the mass is, I'm going to call that mass 1 is 0.70 kilograms. Mass 2 is 0.3 kilograms. V1 is 20 meters per second. And I'm looking for the speed of the bottle, I believe it is. Let me make sure I'm telling you the truth. Yes. They're going to move off together, so the velocity of the ball and the bottle both. So I'm looking for V1 prime, which is equal to V2 prime, which is equal to just plain old V prime since they're moving off together. So I'm going to have M1 V1 plus M2 V2 equals M1 plus M2 V prime. This is 0, so 0.70 kilograms times 20 meters per second is equal to M1 plus M2, which is 0.70 kilograms. Oops, sorry. Plus 0.30 kilograms. V prime. So I have 14 kilogram meters per second on this side. It's going to divide by 1 kilogram coming over from the right-hand side. So V prime is 14 meters per second. Alright, number 8 says Angela rolls her 9 kilogram bowling ball. So the mass of the bowling ball was given to us as 9 kilograms. And the velocity is 12 meters per second. She's going to attempt to hit a pin. And the pin itself has a mass of 2.5 kilograms. The pin was standing still initially. And it says that when she hits the ball is given a velocity of 18 meters per second. So the pin, I'm sorry, I should have said the pin is given a velocity of 18 meters per second. And we want to know the new velocity of the bowling ball. So I have M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. This will be my pin standing still, so this is 9 kilograms times 12 meters per second, so I have 108 kilogram meters per second of momentum is equal to 9 kilograms times V prime plus 2.5 kilograms times 18 meters per second. So that's 45. This is 108. So when I subtract those two, I'm going to get, what, 63? I'm going to divide that by 9 kilograms, and that'll be my V1 prime. So when I did that, I got my V1 prime to be 7 meters per second. Okay, I'm going to stop this one and start another one.